So we're on chapter 3. Crazy, isn't it? So we're only going to do half of 3.1.1 this week. And then the rest we'll just do next week, okay? So with that being said, let's get started. It's more of a review, but just building it up a little bit, okay? So it looks like right here, they're saying the graph is at the right. But I don't know if you're noticing this. Here, the vertex is -3, -5. Oh, actually it is -3, -5. So they did graph it correctly, okay? So they want to know how many solutions does it have. When they're asking for how many solutions, they want to know how many times does it cross the x-axis. And that's twice, okay? And they want to know how is this shown on the graph. It's shown based on the x-intercepts. We could call it the zeros. We could call it the roots. Okay. What if I have this? They want to know how many solutions does that have? Well, let's find out. So I guess I could do that down here. So x plus 3 squared minus 5 equals 4. All right, what would I do first? Add 5. What would I do now? Square root. Plus or minus, remember there's always 2 there. Then -3 minus 3. So I have -3 plus 3, which is x equals 0. And I have -3 minus 3, which is x equals -6. So what's the difference between these two solutions? So I still have two solutions, right? Okay. And how it would be shown on the graph is it would be 0 here and -6 here. Okay. So how is this different than what we've done previously? Well, I want you to see here, are these whole numbers or are they decimals? Okay, so if you look, let me actually solve this one, kind of all over the place today, sorry. If I have y equals x plus 3 squared minus 5, it's really 0 equals x plus 3 squared minus 5. I would add 5 to both sides. I would square root. I can't take the square root of 5, so I get plus or minus or rad 5 equals x plus 3, minus 3 minus 3. And let me pause it real quick, get on Desmos, and show you the decimal equivalent. So I plugged it into Desmos, and I got x equals -0.76, and x equals -5.24. I just rounded, okay? But if you actually look here, let's see. -0.76, yeah, it's close to 1. And then this is in between 5 and 6. So the difference between these two are these are just two whole numbers, and these are two decimals. But how many solutions do I have? I still have 2. And are they real? Yeah, they're real solutions. So let's show that this 0, -6 is here. That's the 2. Okay. And I also want you to do, what if I asked you to find the vertex? Could you find the vertex? Let's see if you remember. Remember, the vertex is halfway in between, so that would be -3. And then some of you go, Miss Rifkin, I knew it from this spot right here. In vertex form, this is y equals x plus 3 squared, move it over, minus 9. So that means my vertex is -3, -9. Or I could take -3 and I could plug it in and see what I would get. Okay? All right, so now okay, we already solved it, so that's done. Talk about and solve other points on the graph. We talked about that. Let me actually graph the green one. Okay. I want you to tell me the difference between this graph, because this is tying in everything we're doing, okay? And the second one, let me zoom out a little bit, which I changed to this. So the pink one was the first one. Oops, I put -5. And the green one was -9. What is the difference between them? And some of you go, hey, this one has a 5 and this one has a 9. I understand. But how would you describe the difference between pink and green? I would say that the green graph is a vertical translation 4 units down. So if you look, it's the exact same graph, but it's 4 units down. And by going 4 units down, it actually looks like it widened it a little bit, but it didn't. Okay. All right. So now what they're going to do is we're just going to do some review. This is what you've done before, right? So what would I do first? Good. Add 5. What would I do now? This should all be a repeat now. I know some of you feel like you've learned a lot, but I also think some of you are seeing that we're just solidifying what you already learned. X equals -3 plus or minus 4. So -3 plus 4, -3 minus 4. And how do you guys know I'm right? How do you know I didn't just make this up? 1 plus 3 is 4, squared is 16, minus 5 is 11. True. -7 plus 3 is -4, squared is 16, minus 5 is 11. Now I know that I'm good to go. Okay? Let's do this one. What would I do? Add 5. And I want you to be careful on this one because I saw some of you on your quiz make this mistake that I'm not happy with. Okay? I do not want you to leave it like this. I do not want you to leave it as a decimal. I need you to birthday cake. So that would be x equals -3 plus or minus 2 rad 2. Or remember, the double goes here. And then what I didn't circle goes on the inside. If I ask for a decimal, then you can give me the decimal answer. I could plug it in Desmos. If I didn't care, you could write it like this. Okay, but I could also plug it into Desmos. Now, would these be whole numbers or decimals? Decimals. Okay, let's see. I want to also point out, let's see if I can find a board. What if I ended up with, let's find a pen here. Let's say if I did -9, okay? What would be the first thing I would do? I would square root. I can't take the square root of a negative number, but I could write it as plus or minus 3i. And then x equals -3 plus or minus 3i. That would be your solving answer. Now, if I asked you how many solutions, you would still say 2, but you would say 2 imaginary solutions. This is 2 real solutions that are whole numbers. These are 2 real solutions that are decimals. These are 2 imaginary numbers. What does that mean? Hey, I could put this in my calculator and I could get an answer. I could put this in my calculator and get an answer. I cannot put this in my calculator and get an answer. So what's the difference in how it would look? This tells me that it crosses at -7 and 1 to make a U. This tells me it crosses in 2 decimal places, I'm just making it up, and crosses there. This tells me that when I graph it, it's going to be somewhere here. It's not going to touch the x-axis, that's why it's imaginary. Okay, we'll work on that more. All right, let's turn the page here. So we've done this before too, and they're just saying, hey, what are different ways that you can solve this? So one way you can solve this is you could subtract 2/5 and then go from there. But I think you remember what I said, and you can do whatever you want, but you need to make sure that you really understand that way and prove it that way, okay? If you're finding the answers online when you're taking a quiz and you can't justify to me that you actually understood that, then I think you copied it off the internet and I'm right, okay? So what I told you guys to do was get rid of the fractions. So I would say this. Here's the most simplistic way. Whatever this is, give it to this. Whatever this is, multiply it there. Whatever this is, multiply it here. Then what would happen is these 4s are gone. This 5 is gone. This 10 is gone. Then you would have 10 and 5, 50, and then you would distribute that there. You'd have 10 times 4 is 40 times 2, distribute it there. Then you'd have 4 times 5 is 45 times 9, distribute it there. But I'm going to challenge you, and I want you to think about why I'm going to do this instead. I'm going to do this. Now, by the way, you can just do what I did. There isn't one way to get the answer. Let me say it again. I don't care how you get it. But if I think you're cheating, I'm right. Okay? So, with that being said, think about why I picked 40. Good. Hopefully some of you got it. Because 4 goes into 40. 5 goes into 40. And 10 goes into 40. That's the least common denominator. Do you have to think of that? No. Could you multiply by 4 and then by 5 and then by 10? Yeah. Could you not do any of that and instead just subtract 2/5? So I could do this instead if I want to, and I want to show it, but just for me, it just doesn't seem the easiest for me. Not judging others, not saying if you do this way, I like you better. Do the way that works for you. If you don't do the way that works for you, then I know I'm not going to like you better. I want you to do the way that works for you without cheating. So the first thing I could do is I could subtract 2/5. And then I would get x minus 5/4. And then I'd have to go 9/10 minus 2/5. Do the least common denominator, which is 4/10. And that would be equals 5/10. And then you could multiply both sides by 4. I want you to see there's a bunch of different ways to do this. For me, that doesn't seem the easiest. For me, getting rid of the fractions, as I've said a million times, is the easiest for me. No judgment. I am definitely not the teacher where I say you have to do it my way. Why is my way better? It's just better for me. So 40 goes into 4 10 times. And then let me show you. Distribute, distribute. So I'm going to show that work here. Okay. So 10x minus 5 plus 5 goes into 40 8 times. 8 times 2 equals 10 goes into 40 4 times. Distribute. Okay. And now I'm just simply going to simplify. 10x minus 50 plus 16 equals 36. 10x minus 34 equals 36. 10x equals 70. X equals 7. Okay? Now, how do you guys know I'm right? I could check my answer by plugging it in. So I'm going to plug in 7. Actually, I'll just do it right here. So I'll show you how to check. Do you have to check it? I don't care if you don't check it. But if you're not correct, you can't be upset with yourself that you didn't check it. Okay? 7 minus 5 is 2. And then you go, well, I can't figure out how to check it. Well, you're going to have to do least common denominator. It's not the best. Or you can go like this, 2/4 plus 2/5 and see if it equals 9/10. Okay? I would go 40 times 10 times 8 times 4. Wait, I feel like I made a mistake. Hold on. I found my mistake. It's the problem with doing stuff in your head. And then times 4. 20 plus 16 is 36, and I keep the common denominator. So I know that I'm good to go. Do you have to check it? No. Do I care? No. Do you care? Well, you care if you're right or not. Okay, what's another way to do this problem? You figure out whatever you want to do. We already talked about that. Subtracting 2/5. You can multiply by 4, 4, 4, 5, 5, 5, 10, 10, 10, and so on and so forth. Okay? All right, let's go to the next one. This next problem, you see this here. Now, what makes this difficult? You've solved things before, but what makes this difficult is that it's decimals. Okay? So they're saying do the quadratic formula. Yeah, we can do the quadratic formula down here. But I'm going to show you a different way that I would do it. I know 2.5 is the same thing as 5/2. And I know 1.5 is the same thing as 3/2. I'm going to see if I can show you that on decimals. One sec. So I took 1.5 and I literally just pressed that button and it told me 3/2. I did 2.5, I pressed the button, I got 5/2. Okay? So now you go, well, Miss Rifkin, I don't get it. It doesn't make it any easier. But what if I multiplied everything, because what do I hate? Fractions, by 2. Okay? Then I would get 2x plus by, oops, sorry, that's a squared, plus 5x, and then I multiply by 2, by minus 3. What's any number times 0? 0. Ah, now there's no fractions. Now for me, this is when I do my cute little magic x. And I'd go -6, -5, two numbers that multiply and add. Let me zoom that in a little bit. I know some of you, that's kind of the issue with the ed puzzles. Keep me on my toes. So then I get -6 and 1. But remember what I have to do if I have the 2 in front. And you have your way, that's fine. You need to show work though, okay? Otherwise, you know the drill. You know how I'm going to finish this sentence. I think you cheated. And then what you do is you go, hey, divide by 2, x minus 3, so x equals 3. Then I come over here. I can't do anything. Set that equal to 0. X equals -1/2. Okay. I'm going to have to do quadratic formula on the next video.